Good morning, students. In the previous two classes of triangles, we have understood what is congruency and about the criteria of congruency. Now, in the criteria, we have started with SAS, ASA, SSS, and RHS. Now, in today's class, we are dealing with AAS. This is the fifth criteria. Now, as the name states, it is angle, side. That means in two triangles, A, B, C, D, E, F. Angle, that means this angle, and then another angle, second angle, and then side. Now in this case, we are checking any two angles and that side. Any two angles, that side. But when you are checking the angles, no, it has to be continuous. Same thing it has to be. Now if I take here angle, it will not. It has to be one continuous cycle. Okay? Angle, side. Angle, side. So, in two triangles, in triangle ABC and in triangle DEF, if angle A is equal to angle B, angle B is equal to angle E, and BC is equal to EF. Therefore, triangle ABC is congruent to triangle DEF. Okay? Triangle ABC is congruent to triangle DEF. Now again, angle, side. As I told you, the moment when you prove two triangles are congruent, which things will be equal again? What is remaining in this? Remaining is angle C is equal to angle F. And then AC is equal to DF. And then what is remaining? A is equal to B. See, always remember that the moment when you prove three things are equal and you conclude that both are congruent, the remaining three things automatically will be equal. And that is why it is called as CPCT. CPCT means congruent parts of congruent triangles are always equal. So if you want this to be equal, this has to be done first. To do this one, you have to check all these things. So all are interrelated. Now this is the fifth criteria. So in total, what are the criteria we did from last three classes? The first one is SAS. Second one is ASA, SSS, RHS, AAS. These are the 5 criteria. Now, let's see a few examples based on all these criteria. The first one is example 1, page number 86. If you see this, in the figure, OA is equal to OB, OD is equal to OC. Show that AOD is congruent to triangle BOC. Now here they have given a diagram like this. Now in the question, what is given? Write it as given. Just OA is equal to OB. And then OD is equal to OC. What do we have to prove? What do we have to prove? We have to prove that triangle AOB is congruent to triangle BOC. This is the first one. Second one, AD parallel to BC. These are the two things which we have to prove. Now here, if you see this, they have given OA and OB are equal. Whereas this is no. That means this. See, this is the first triangle, this is the second triangle. This side equal to this side. This is the first thing they have told. Second, OD. This is a single line. This equal to this. If I draw this separately, same triangle. This is triangle 1, triangle 2. See, this point is O. This point is O. OC. If I write OC, OC and OD are equal. So I have to write D here. And if I write B here, this is A. Same these two triangles I have drawn separately here. Now, as per the condition, OE is equal to OB. Where's OA? This line equal to this line. That, and then this equal to this. Two things we have. Two sides are equal to two sides. Now, if you see these two angles, what do you call these two angles? When two lines intersect like this, we get these four angles. What are those angles called? Those angles are called as vertically opposite. And vertically opposite angles are always equal. Remember that. So I can conclude here, these two angles are equal. That means this angle equal to this. If you see here, this is side. This is A. This is side. This is side, angle, side. Now once when you get everything, you can start with proof. You can start with OA in triangle AOD and triangle BOC. That means in these two triangles, OA is equal to OB. How do we know these two are equal? Because it is already given in the question. So in the bracket, write given. Now the next one we checked was BOC, angle BOC. Angle BOC is equal to angle AOD. Why these two are equal? Because those are vertically opposite angles. Last, OD is equal to OC. Why these two are equal? Because it is already given in the question. Once when you have SAS, you can conclude as per SAS. Triangle AOD congruent to triangle BOC. So the first part is done. So whatever the information they have given, you just have to write it in order. You have to understand the diagram and based on that you have to write. So the first part is done. Now we are left with the second part. How do we prove that? Okay, let's do one. I'll erase this one. See, always remember Even when I was explaining the criteria, I was telling you the moment when you prove two triangles are congruent, the corresponding parts will always be equal. Now in this case, which is the corresponding parts? We know that triangle AOD congruent to triangle BOC. Hence, which are the corresponding parts? This angle, this angle, this angle, this angle. So can I write angle A is equal to angle B and angle D is equal to angle C. Why these two are equal? Because corresponding parts of congruent triangles are equal. So if you see these two angles, usually I'm sure you know about the alternate angles. These alternate angles comes only when there is a parallel line. Now these two are the alternate angles. Now if these two are alternate angles, I'm sure there should be two parallel lines. So the two parallel lines are nothing but these two. Therefore, they are alternate angles. If they are alternate angles, then it is AD is parallel to this. This is how we concluded. Okay, students, the next problem is exercise 5.1. In exercise 5.1, the first problem they've given us in a triangle, in a quadrilateral ABCD. This is a complete quadrilateral ABCD. Okay? In this quadrilateral, they have given, it is all given, AC is equal to AD. So here AC is equal to AD. And then angle A, this complete angle, it has been bisected by AB. If AB is bisecting this complete angle, these two angles are equal. See here, CAB is equal to DAB. Written. Okay? And these are the things which is given in the question. What are they asking us to prove? They are asking us to prove that these two triangles are congruent. It is nothing but ABC and AD. So to prove this, just to make it simple, let's draw two different triangles. Same thing. They are asking what? ABC, AD. See here? ABC, AD. Write down these two triangles. Whatever given, just enter there. First is AC and AD. See, these two are equal. Second, this angle equal. That means this angle equal to this. These are the two things given. Now, how do we prove having only these two things? The third one. If you see this AB here, even I have AD here also. Why we have the same thing is because this complete quadrilateral have a AB as a common sign. So we can conclude as AB equal to AD. Now we have sine, angle, sine. Sine, angle, sine. Whatever we have, we will just write down. What do we have to prove? We have to prove these two. Triangle ABC congruent to triangle ADB. Next, proof in triangle ABC and ADB, that is in those two triangles. We already know AC is equal to AD because it is given. I have written given. Next, CAB is equal to DAB, CAB is equal to DAB. It is already given. Third one, which is common, AB and AB, same thing as AB and AB common. So we have three things here, which is sine, angle, sine. So as per SAS criteria, we can conclude that both the triangles are congruent. Okay? See, whatever we have to prove about the congruency, 90% of the information is already given in the question. You just have to make it note in an order. The moment when you get all those in an order, you can directly conclude to prove it. This is how we do. Now this congruency, little tricky, but it is very important. Ensure that if you have any doubts to clarify on the same day. Okay? And we will always have an interaction day to have any kind of a clarification or any questions. Thank you so much, and we will continue the next class. Bye students.